On a remote Austrian hilltop, a new facility opens to help improve the detection of nuclear explosions worldwide. It's an infrasound testbed to conduct research on technologies used to monitor the planet for nuclear tests. Infrasound arrays like this can detect low-frequency sound waves inaudible to humans.
When you see or feel the wind here, that's already wind or air pressure moving. That's what you feel on the face. When there's a nuclear explosion, the same thing happens. There is a pressure wave moving for thousands of kilometers, but you don't feel it. You cannot hear it, but we have a special sensor that can register, that can see this pressure wave moving through the air. So that's why we have this here, this very sensitive sensor, because you cannot hear it, cannot see it, but we can measure it.
The CTBTO installed the equipment. It's building a network of 337 facilities dotted across the globe. They send data in near real time to the International Data Center in Vienna to watch the globe for nuclear tests.
We have a worldwide network, and we're using equipment and we're using wind noise reducing systems, which means if the wind is like this, we cannot see our signal. So we have to reduce the wind noise. That's why you see all these pipes here. And the reason why we have this one here, we want to develop it further, our network, we want to improve it. And we needed a test environment where we could easily do it. All the stations which are already installed, we are not allowed to touch. You know, the data is forwarded to Vienna and it's official and you shouldn't touch that station. But here we can do all the tests to improve our IMS, the infrasound network.
It's co-located at Austria's Conrad Observatory, where seismometers monitor waves in the ground for earthquakes. The technology also registers underground nuclear tests. It's the perfect location for the new facility. Scientists and diplomats heard at the opening.
The goal to assess the added value for verification by co-locating infrasound and seismic sensors. Then to conduct equipment tests and noise reduction studies. And last but not least, to provide hands-on equipment training to CTBTO station operators, both in the infrasound and seismic technologies.
It will help to strengthen the performance of the CTBTO's network as it watches the world for nuclear explosions.